This is a massive C5 Galaxy. It even has a cute little nickname, Fred. You'll see why in a minute. However, that's the only little thing about it. Fred is gigantic. The C5 is 247 long, 65 feet high, and has a 222-foot wingspan. But why does it need to be so big? Well, there are multiple reasons, and it starts with a cargo component which is 121 feet long, excluding ramps, 19 feet wide, and 13.5 feet high. That's because it needs to carry all kinds of equipment all over the world. The Galaxy can carry tanks like the M1A2 Abrams, of course, but that's just the beginning. It has a standard payload capacity of 240,000 pounds that can be increased up to 291,000 in wartime. Its maximum takeoff weight in wartime is a staggering 840,000 pounds. The C5 has more wonders in its bulk, though. This plane is versatile. It has 73 passenger seats in the rear upper deck and 8 in the forward upper deck, but they face backward, toward the tail. Why? Well, remember that this is primarily a cargo aircraft, not a passenger one. The rear-facing seats allow the Galaxy to maximize its cargo mission. The seats make it easier to access the cargo area and maximize the space for the optimal arrangement of both crew and supplies. It's safer, too. It means the plane can be evacuated more quickly in an emergency, and there's more mitigation in cases of turbulence or hard landings. Passengers facing the tail will experience less stress in such events, preventing injuries. But for all these marvels, the C5 hasn't come without controversy. The latest C5M Super Galaxy variant costs $57,508 per flight hour as of August 2024. The high cost comes partially because of the rigorous demands of its early development. The program began in 1963, when the U.S. military realized it needed a jet to replace its C-133 Cargo Master. Lockheed won the bidding process and began to build an aircraft that made everything else in existence look paltry. But it needed to meet high expectations. To be considered a success, it had to carry a payload of 125,000 pounds over 8,000 miles, and twice that over shorter ranges. It had to be able to take off on runways of 8,000 feet in length and land on runways only 4,000 feet long. The most controversial requirement was that the United C-5 A-frame could survive for 30,000 flight hours. Lockheed seemed to meet all of these requirements when the plane made its debut in December 1969, but problems came almost immediately. Wing cracks showed up in the fleet by the mid-1970s, which forced all C-5A aircraft to lower their payloads to 50,000 pounds. As a result, the C-5 fleet was re-winged between 1981 and 1987 with aluminum alloy wings that hadn't been available during the initial rollout period. Later versions came with further improvements in wings. They last longer now, engines, and flight control systems. The C-5C version made better use of the cargo area, removing the troop compartment located in the aft upper deck and modifying the aft cargo door complex. Both of these changes increase the size of the cargo compartment's offloading area. Now that you know all of these things, you might have guessed that Fred is actually a bigger name than it seems. It's called that because it's a slang acronym for freaking ridiculous economic disaster. Except they don't use the word freaking. The Galaxy might have painful cost overruns and be expensive as hell to fly, but it's so damn cool, and we haven't even touched on some of the coolest stuff yet. The engineers thought about the loading challenges on a plane this tall, too, which is why this behemoth can lower itself to your level. It can kneel, or rather its landing gear can. When parked, the C-5's landing gear can retract until it is mostly underneath the belly of the plane. That makes it easier to deploy its ramp to load and unload cargo. That sounds easy, but remember that this plane weighs 400 tons, not including all the other stuff it carries. How does it not collapse under its own weight when using its landing gear? Well, the Galaxy has a high-flotation landing system that allows the aircraft to distribute its weight over a large area, which means it can land on relatively short and unprepared runways. For better flexibility, the landing gear can even raise or lower each set of wheels individually. This feature helps to simplify tire changes or brake maintenance. Each C-5 Galaxy has 28 wheels that can do this, asterisk note editor to show how landing gear rotates 90 degrees, for better stowage. Stowage is the ability to organize cargo and equipment on a vehicle like an aircraft or ship. For the C-5 Galaxy, the wheels enable strategic placement of cargo in the optimal way, but that doesn't mean this is an easy task. In a commercial aircraft, cargo would typically be loaded using forklifts, lift trucks, or scissor lifts. Naturally, this isn't possible if you're trying to load a 147,000-pound Abrams tank. So the plane has to come to you instead. That's why it kneels. That way, the cargo deck is aligned with the equipment that needs to come onto the aircraft. But as you might have guessed, there's more tricks that make loading cargo onto the C-5 incredibly efficient. Don't just look behind. Look at the nose. 2. Do you see this? That's a C-5 Galaxy turning its nose up at you. No, it's not to be rude. It's doing that to make its life easier. The C-5's nose opens to the full width and height of the cargo compartment. That's enough for tanks to drive through, and because cargo can be loaded from both the nose and the tail, it's a lot easier to get things loaded onto the Galaxy quickly and in the most efficient spatial arrangement. On a typical plane, all the cargo will be loaded from only one direction, the rear, which takes a lot more time. The United States has 170,000 troops in 40% of the world's nations. These troops need constant supplies and equipment across a wide range of environments. The C-5's engineering to reduce load time is one of the reasons these troops can be confident they'll have what they need to respond quickly to disasters and emergencies. But there's more. A lot more. How does the C-5 get such heavy cargo around the world and not fall out of the sky? To understand this, let's first understand how much power it takes to lift 840,000 pounds off the ground in the first place. Well, the latest version, the C-5M Super Galaxy, has 4 turbofan engines that generate 51,250 pounds of thrust each. That's a combined total of 205,000 pounds. For comparison, a fighter jet like the F-16's engine can only generate a maximum of 32,500 pounds. The Galaxy simply dwarfs everything else. But maintaining such powerhouse engines isn't easy, and that's one reason why the C-5 is such an expensive aircraft to fly. Keeping the engines in proper repair requires frequent upkeep and costly specialized procedures like programmed depot maintenance, which almost completely disassembles the aircraft so that each part can be inspected for defects. Each Galaxy must go through this procedure every 96 months. To make things a little easier, the Air Force upgraded its engines from the General Electric TF-39 to the General Electric F-138. The new engines have 22% more thrust, a 30% shorter takeoff roll, and a 58% faster climb rate, so it can carry more cargo over longer distances. Although costly, the engines can pull off even more cool things like in-flight thrust reversal to decelerate. The Galaxy can descend rapidly thanks to them, too, at 18,000 feet per minute. In fact, the C-5's engines are so powerful that the design of the aircraft itself had to be changed to accommodate them. Take a look at the tail. Clearly it's big, 65 feet high in fact. But why, exactly, does Fred's tail need to be this high? Well, it's definitely not to win first place in any beauty contest. Rather, it allows for a large cargo hatch and ramp at the rear of the aircraft to make hosting large and oversized cargo easier. The high T-tail design means the plane's tail is safely out of the way of disturbed airflow behind the wings and engines, providing horizontal stability. The design is advantageous for cargo planes like the C-5, but that doesn't come without challenges. T-tails like the Galaxies are prone to deep stalls, where airflow separated from the wing during a stall tilts the aircraft up and makes it hard for the pilot to control. There was a close call in 1998 when a C-5 experienced a stall on approach to Diego Garcia in the Indian Ocean and almost crashed. To counter this possibility, the C-5's wings are designed to provide adequate lift and stability at various angles of attack, including in stall conditions where a wing can no longer produce lift efficiently. Advanced flight control systems and extensive training for pilots enable recognition, prevention, and recovery from stall conditions. Specifically, pilots are trained to reduce the angle of attack and increase thrust to regain lift and control, and they fortunately have mighty engines to do it with. Thanks to these attributes and regular maintenance, the C-5's T-tail is safe and improves its ability to do what it does best, get heavy stuff anywhere in the world. The C-5 might have had a controversial design history, but its record tells a story. It's been in service in one form or another for many years, and there's no plans to retire it anytime soon. How does the Air Force plan to keep it up to date? You already saw the new engines, but they are just a start. The newest C-5M Super Galaxy boasts new avionics, like 6 multifunction smart displays that provide precise flight and navigation information. All 6 of them are 15 inches and are part of CMC Electronics PU3000 multiple avionics computer. This is the first avionics computer to use multiple processing, which means it will do what a computer needs to do a lot faster than the system it replaced. These upgrades began in June 2022. There's a maintenance diagnostic system which analyzes over 7,000 test points. With an automated system to record emerging problems on the plane, human operators will be able to respond with quicker fixes. That means reduced repair time that can hopefully ease up on the cost per flight hour. There's also better cockpit controls with higher resolution displays, so the Galaxy will be better able to surveil the area it's flying into and react to emerging problems. There's hardware upgrades, too. Structural enhancements that make the Super Galaxy more durable, like a reinforced A-frame that can handle more stress during flight. Future upgrades will include advanced weather radar, new communication systems, and better air traffic management that will meet FAA mandates and enhance in-theater survivability. With these new systems in place, the C5 Galaxy is expected to remain in service until at least the 2040s, 70 years after its introduction. That's a testament to its engineering, versatility, and unique ability to do a job no other aircraft can. Bye for now.